Okay, so this will be part 2 of the lecture 1 video. Okay, so like we said before we got interrupted, the 1 over cos squared we can rewrite as sec squared. So let's put this as the integral 1 over root 1 plus tan x, and let's put the sec squared on the side here. Okay, so that motivates us to choose u to be that bottom bit there. Now there's two options. We can either let u be 1 plus tan x, okay, that's one option, or we could say u is the root of 1 plus tan x. You can do it either way. I'll do it the first way. Homework, that will be the second way. So u equals 1 plus tan x, and then just a little note here, homework, u equals the root of 1 plus tan x. You'll get the same answer. It's just the du part is a little bit different. Okay, but please do try that for homework. Okay, we know this already. Derivative of tan, that's going to be sec squared. So all of this gets replaced with this, and then that just becomes 1 over root u. So that's the integral 1 over root u du. Okay, it looks a bit funny, but remember this is just u to the minus half. So that's integral u to the minus half du. Add 1 to the exponent, that makes it a half. Divide by a half, that's times 2. So that's 2u to the half plus c. U is 1 plus tan x, so we can fill that in. To the half plus c. Okay, and then please check your homework. With that other substitution, you should get the same answer. Okay, so that was number 4. Number 5. Okay, we have the integral of sine x over cos squared x dx. Okay, quite easy. We've got two options here. If u is sine, then du is cos, but we've got cos in the bottom, so that doesn't help. If u is cos, then du is minus sine, and we've got sine at the top, so we go with that one. Okay, so in later lectures, I won't go through that reasoning. I'll just say u is this, and you should know the reasoning behind it. So u is cos, du is minus sine. Take the minus over, and we get sine x dx, and that takes care of the top part. So this just becomes the integral of 1 over u squared. Everything else is du. You can take the minus out. That will be u to the minus 2 du. So add 1 to the exponent, that's minus 1. Divide by that, that gets rid of the minus we have there. So that's u to the minus 1 plus c. U is cos, so that's just cos x to the minus 1 plus c. That's not inverse, that's reciprocal. So this is 1 over cos. Okay, please don't think that that is arc cos. Okay, the minus 1 is on the outside, so it's 1 over cos. Okay, any questions so far? Oh, good. Okay, that's number 5. Number 6. We have the integral of 1 over 5 minus 3x dx. Okay, pretty easy. There's only one thing we can do. We can say u is that bottom bit over there. So u is 5 minus 3x. Du is minus 3 dx. Okay, we don't have a minus 3 there, so let's take it over to the other side. So minus a third du is dx. So this becomes minus a third integral 1 over u du. Again. Okay, so process of elimination, it must be the projector. The recording looks like it's still going. Okay, no. Okay, no, recording's still going. Weird, but let's carry on. Again. Okay, what do you think's cheaper, putting in a chalkboard or getting a new projector? Yeah. Okay, I'll make a complaint, see what we can get for next week. unless we can move to the comp plan. Class rep again, can you take a jog to the comp plan to see if anyone's there? Thank you. Yes, thank you, class rep. Okay. Okay. So if this does become a problem next week, we're going to move to the comp plan provided there's no lectures there. So we'll see what he says. If they do have a lecture there, I'll see if we can go to the S block. Maybe there's something free over there. Okay. So we have minus a third. Integral of this, we know natural log of u plus c. So this will be minus a third natural log 5 minus 3x plus c. Okay, pretty easy. Okay, number 7. No lecture. Okay, sure. So I'll make the complaints about the projector, and then next week, if it's fixed, we'll stay here. Otherwise, I'll send an email and we'll just meet in the comp plan. Okay. 7, this comes with a little star. Okay, it's a little bit different to the other ones. So this is the integral of 1 plus x over 1 plus x squared. Okay, so the reason there's a little star is this is the first integral where we have to do something a bit more than u substitution. So let's just imagine we did u substitution by itself. If we let u be the bottom part, du is going to be 2x. We've got x, but it comes with a plus 1. That's a problem. We can't work with that. So what we're going to do is split this up into 2 integrals. The one integral we can do right away. The second integral, we can do u substitution. Okay, so again, there's a bit more thinking behind this one. So here, we're going to split it up. Instead of 1 plus x at the top, it's going to be 1 over the denominator for the first part, x over the denominator for the second part. So 1 over 1 plus x squared dx for the first part, x over 1 plus x squared dx for the second part. I think you can see why we did that now. Because the second part has the x. If we let u be the bottom part, we can clear the top. The first part, that's just arctan. So quite easy to do. So this is going to be tan inverse x, straightforward. But for the second part, let's do the u substitution. So u is going to be 1 plus x squared. So du will be 2x dx. Here we've just got an x, so let's take the 2 over. So 1/2 du is x dx. So this will be 1/2 integral 1 over u du. Okay, don't worry about the x's and the u's being on the same line. We'll fix that after this. So we've got tan inverse x plus 1/2 log of u plus c. Okay, and finally arctan x plus 1/2 the log 1 plus x squared plus c. Okay, now everything's fine. Everything's in terms of x. Okay, but again, we'll see later on, there's a few questions like this where we need to split up the integral or do something first. It's not always just let u be this, du is this. Okay, there can be some other steps involved. Okay, so just in your books, put a little star there to remind you. Okay, 8. Okay, a little star. Again, this one's a little bit more difficult. In other words, it's not just let u be this, du is that. A little bit more work. So we have the integral of x over 1 plus x to the 4 dx. Okay. Again, if we just let u be the bottom part, then du will be 4x cubed. In the top, we've got x, not x cubed. So we need to do a little bit more working to get x, not x cubed. Okay, but we start as normal. U is 1 plus x to the 4. Du is 4x cubed dx. Okay. Now, what do we want to do? We want to get to x. We've got that over there. What can we do? Yes? Factorize? No, can't do any factorizing. Okay, think about what we did yesterday as one of the problems over here. Where was it? Something like number 4. Okay, look back to what we did yesterday, number 4. Yep. Yeah, so we've got 3, we want to get the exponent down to 1. So what do we multiply by? Good. How do we get that? Yeah, so we can take the 4 across. So we've got 1/4 du is x cubed dx. Yeah, so that takes care of the right-hand side, and then the left-hand side. Okay, so we got what we want to do, but how do we do it? Yes? No. No. Yeah. Okay, so then what do we do with the u? Okay, so we solve for x to the 4. So u minus 1 equals x to the 4. And then we can do what do we need? We wanted the x squared, right? So we've got x to the 4, we want x squared. What do? Square root, yeah. Okay, good. Okay, so we've got that. Now we just put that on both sides. So we've got 1/4 1 over root u minus 1 du is equal to x cubed over the x squared. That gives us the x that we need. Okay, good. Yeah, very similar to what we did with that number 4 from yesterday. So this becomes 1/4 integral x dx. That's going to become that fraction over there. And then we've still got the 1 plus x to the 4 to deal with. So we're going to have 1 over 1 plus x to the 4. That's going to be a u. And then we're going to have u minus 1 du. Okay. Looks good. Now this looks similar to one we did earlier, number 3. We've got the x and the root x plus 2. Now we've got the u and the root u minus 1. So we're going to have to do a second u substitution. So we've done one u substitution, we got this. Now we have to do it again. Okay, so u substitution can be done multiple times. In the easier cases, you only have to do it once. For something like this, you have to do it twice. In another example coming up, you have to do it 3 times. Okay, so it's not just a one-time thing. Okay, so for this one, I'll put in the substitution and then you can finish the rest. So let's call it a T substitution. We have to pick a different letter. You can pick, so we've got U, you can pick V, A, B, C, whatever you want. Let's go with T. So let T be equal to, now there's 2 options. You can either let it be that inside bit U minus 1, or you can let it be root of U minus 1. Let's go with the root U minus 1. Okay, I'll do the dt part and then you can put it all together for homework. So dt, that's going to be 1 over 2 root u minus 1 du. Okay, can take the 2 over to the other side. So 2 dt is 1 over root u minus 1 du. And that takes care of that bit. You can do the rest for homework. Okay, so you've got what t is, you've got dt, sub it in, and then you can just do the integral right away. Now, remember, when you get your answer in terms of t, you need to substitute back for u, and then once it's u, you substitute back for x, okay, because you've got the 2 substitution steps. So remember that the answer must be in terms of x. Okay, so don't leave your answer as t, don't leave it as u, it must be x. Okay, number 9, we have the integral of cot x dx. Okay, you might have memorized this from last year, but if not, we'll go through it again. Cot x dx, okay, if you don't know what it is right away, you just need to know that cot is 1 over tan. So if tan is going to be sine over cos, then cot is cos over sine. It's the other way around. Okay, and this helps us nicely. If we let u be sine, du is cos x dx, that takes care of the top, and we're pretty much done. So if u is sine, du is cos x dx, that takes care of the top. So this becomes the integral 1 over u du. So that will be log of u plus c, and u is sine, so we just put that in. So then this will be log of sine. Okay, so you might have seen this last semester when we did the trig integrals, but if you forgot it, you can do it like this. Okay. Remember the integral of tan. I'll leave that for homework there. You can do it on the side. That will be something with log of cos, but then you'll get a minus sign. Okay, so integral tan. Okay, so it'll be very similar. So instead of cos over sine, it'll be sine over cos, and then you'll get an extra minus sign. Okay, 10. So we have the integral 1 over x root log x dx. Okay. Like with the other examples, there's more than one way to do a u substitution. Here we're going to let u be root of log of x. See what happens. Okay, u is root of log of x. Okay, so du, by the chain rule, we're going to have 1/2, 1 over that. So 1/2, 1 over root log x times, and then the derivative of the inside, that's the derivative of log, that's 1 over x. Okay, that's interesting. We got 1 over root log x, 1 over x. That's the entire integral, apart from the half. So we can take that over. So we're going to have 2 du is 1 over x root log x dx. And that replaces the entire integral. So this just becomes 2 times the integral of du, or you can put a 1 there if you want. But this is just going to be 2u plus c, so that will be 2, whatever u was, that's the root log x, plus c. Okay. You could have done it the other way. You could have said u is just the natural log, then the du will be 1 over x, and you end up with the integral of 1 over root u. You end up with the same thing. So I'll just make a little note here. Or u equals natural log of x. You can do either one. We'll see later on in the coming weeks. Given some integral problem, there's a number of ways of solving it. Not just different u substitutions, but completely different techniques. So you can do U substitution, integration by parts, partial fraction decomposition. There's quite a lot to do. Okay. For tests and exams, it's up to you to decide. Okay. For class test 1, I'll tell you which method to use. So it will be like question 1 is U substitution problems, question 2, integration by parts problems, just to give you a hint on what to do. For the June test and the exam, you just get a list. It's just going to be a list of problems all mixed up, and you're going to have to figure out what to do. Okay. Just a note for the June test with this. If you do have time and you want to answer the question multiple ways, I will give you the marks for both. Okay. So if the question is out of 5 and you can do it with the U substitution and you can do it with integration by parts, you get 10 out of 5. And that will be for every question. So just keep that in mind. I will remind you as we go through, but that is my policy on marking that. Okay, next. Oops. Number 11. Okay, we're supposed to finish 10:30, I think. Okay. We'll do a couple more and then the rest I'll leave for homework. We've still got quite a bit to do. Okay, 11. Integral x e to the minus x squared dx. Okay, again, quite obvious. We've got an outside function, which is an exponential, inside function, which is minus x squared. We let u be the inside. Okay, so du is minus 2x dx. We don't want the minus 2, we just want the x. So this becomes minus 1/2 du is x dx. That takes care of all of that in the front there. So that's going to be minus 1/2 integral e to the u du. The integral of an exponential is the exponential. So that's minus 1/2 e to the u plus c. So that's minus 1/2 e to the minus x squared plus c. Easy stuff. Okay, outside function, inside function. You should know what to do by now. Okay, number 12. So this is the integral e to the x plus 1 over e to the x plus x. Okay, just a little helpful hint. Whenever you've got a fraction, if you let u be the denominator, it usually works out. Okay, so here if we let u be e to the x plus x, du will be e to the x plus 1, which is what we have at the top. So that works out here. So u is e to the x plus x. Du will be e to the x plus 1. That takes care of the top. So we just have 1 over u. Okay, but that's just the log. And then we can substitute back. Okay, easy stuff. Okay, the rest I will leave for homework. Okay, remember the solutions are posted, but try them out first. Okay, because if you look at the solutions first, you might think, okay, that's easy, but could you have figured that out in like a test? Okay, maybe not, maybe, but looking at the solutions first, never really a good idea. Okay, so the rest, this will be for homework. So that's the integral of log x squared over x dx. Okay, integral of sine to x over 1 plus cos squared. Okay, for number 14, think about your trig identities. Half angle, double angle, those things. Okay, 15, integral sine x, so just sine x, not sine 2x, over 1 plus cos squared. 16, integral of cosec x cotan x. Okay, again, think about what these are. Cosec, 1 over something. Cot, 1 over something. Think about that. 17, integral x to the 5 roots 1 plus x squared. Okay, think about what we did for number 8. Okay, so hint number 8. Okay, 18 integral x over root 1 plus 2x. Okay, pretty straightforward for that one. Okay, 19 integral of x squared over 1 plus x cubed. Okay, that's just a direct u substitution, nothing difficult there. And 20, little star here, integral of x squared over 1 plus x squared. Okay, think about what we did for number 7. Okay, so those will be for homework. Again, no one's checking, but I do suggest you do these, especially the ones with the star that we've done today. Okay, please go over those again. Okay, and then a bonus one. Okay, we have dx over 1 plus root x to the 4. Okay, if you can solve this first and show me in my office, you will get 5% extra in the next quiz. Okay, first person. Okay, and you have to explain your steps, right? Don't just give me the answer. I want to see u equals something and so on. Okay, so someone's already got 5% for the quiz. Next one will also be 5%. Also, class rep, if you do get this, then it will be 10%. Okay, so. Okay, next thing, use substitution with bounds. So for all of the problems we've looked at so far, those were just indefinite integrals. Now we're going to look at what happens if you're going from A to B. So use substitution with bounds. In other words, definite integrals. Okay, and with this comes all of those definite integral properties from last semester. Okay, we had the whole list and we did the proofs for all of them. All of those properties you will be using with this. Okay, just like we used them last semester. Okay, so here we have the integral from A to B. We're including the bounds now. We're going to have f of g of x, g prime of x dx, same as before. Okay, outside function, inside function, but now we're going from A to B. Okay, the method is exactly the same, apart from one extra step. So let u be g of x. So du will be g prime of x dx. Okay, but that takes care of the function and the differential. But remember the bounds. We can rewrite the bounds as x equals a to x equals b, because everything is in terms of x, including the bounds. Now, if the integral is rewritten in terms of u, the bounds need to be rewritten in terms of u, because those are x bounds. We need to get u bounds. So this step, that's what we covered before. And extra step, if x is equal to a, then u is going to be g of a, just by substitution. And if x is equal to b, u is going to be g of b. Okay, so apart from that first bit, we got this extra little bit, but everything else remains the same. So this now becomes the integral, now with u bounds. So it's going to be u equals g of a to u equals g of b. I'm not going to write the u equals later on. F of u, and then everything else is du. Okay, everything else exactly the same, except the change of bounds. Okay, that's the only extra bit. Okay, and now the first proof of the year. How does this even work? So proof. Okay, there's going to be quite a few proofs this year. Please make sure you learn them. Okay, so for the exam, it will be between 20 and 25% proofs, and then the leftover will just be calculations. Okay, so around a quarter of the final exam will be proof questions. So show that something, you need to show it, or prove that something, or a proof that you've seen, something like this. Okay, so let f and g be two functions such that f is continuous. Quick show of hands, who's forgotten what continuity means? Okay, so everyone knows what continuous means. Okay, good. And g is integrable. Okay, quick show of hands, who forgot what integrable means? So everyone knows. You don't know. Okay, go back to last year's notes under the section. No. Last year's notes section on Riemann integrability. Please recap that. Okay. Now, I'm not your MATH160 lecturer. I'm your MATH161 lecturer. Okay. Afterwards, you can go see the 160 lecturer. He'll help you out. Okay. So G is integrable on the interval a to b. Okay, this a to b is whatever a to b we have for the integral. Okay, since f is continuous, it has an antiderivative. Okay, I really hope you haven't forgotten what antiderivative is. It has an antiderivative, capital F. Right, whenever we've got a function little f, the antiderivative we call big F. Yes? What's that? Oh, you want your points now. Not quite. Almost. A little bit more. Okay. Okay, someone's eager for the 5%. Okay, next time when I do, have the 5% things, please see me afterwards. Okay. So since f is continuous, it has an antiderivative capital F. Okay, whenever we got the little f, capital F, that's the antiderivative. Okay, next, consider. Okay, so we're going to have the following expression. It looks a bit weird, but we'll see why it works. So we have f of g prime x. Okay, so we've got this composition of the antiderivative and g. Why? Well, let's find out what the derivative is, and we'll see why we have this. Okay, so chain rule, derivative of the outside. So that's going to be capital F prime of g of x times then the derivative of the inside, that's the little g prime. Okay, again, it might still look a bit weird, but remember, capital F is the antiderivative. So capital F prime is just little f. Okay, does everyone see that? The derivative of the antiderivative is just the function. Okay, please go over your antiderivative notes if you don't see that, that step there. Okay, so why does this help? Well, look at what we've got here. Okay, f of g, g prime. If we go up a bit, that's this here. Okay, that's the integral. Okay, so what we're going to do is integrate both sides. So we're going to have the integral from a to b, okay, of our integral here, this bit thing. Okay, which is what we wanted for this first line. Okay, so integral a to b, f of g of x times g prime of x dx is equal to, and now we're just going to replace that inside part with what we have there on the left. Okay, so this is going to be the integral from a to b, and we're just going to replace it with that left-hand side. So that's going to be f of g prime dx. Okay, now remember your fundamental theorem of calculus part 1 and 2. The integral of the derivative is just the function back. The derivative of the antiderivative is the function. The integral of the derivative is the function. Right? It was that FTC that we went through. So this is just going to be the function without the derivative, so just f of g. So this will be f of g evaluated at the bounds. Okay, that's just from your FTC. So just on the side, if you've forgotten, the integral from a to b, f of x dx, that was f at b minus f at a. Okay, so we just use that. Okay, anyone lost so far? Okay, so we just took the integral, we replaced it with that left-hand side, and then we used FTC to rewrite it like this. Okay. Now we're going to use FTC again. So we're going to start with the difference of the antiderivatives and go backwards here. So this is going to be the integral. This is the inside part, right? And capital F, that's the antiderivative. So this is the integral from g of a to g of b, f of something, let's call it u. Okay, so we just went backwards. So here, instead of f at b minus f at a, we wrote it as an integral. So this, these two steps here, this is just FTC. Okay, if you're unfamiliar with that, please go back to your notes, the FTC1 and the FTC2. Okay, and we're done. We started with that integral there, and we've got the integral on the right in terms of u. Okay, so that's the end of the proof. Please make sure you know that. Yes? Yep. Yeah, so this is just from our FTC on definite integrals. So the integral, the Riemann integral of some function is just the antiderivative evaluated at the bounds. Remember, we wrote it like this. That thing. Okay. Any other questions? Yep. Which part? Further. This bit. Yeah? Oh, okay. No, that's fine. Yeah, so all of this is exactly the same as what we did yesterday, except now we are changing the bounds. So this bit here and this, that's the only new thing. So capital F is the antiderivative. The derivative of the antiderivative is the function. So by definition, f prime is f. Okay, that's the definition of the antiderivative. Okay. Anything else? Okay, let's have a look at some problems. Okay, so the working is pretty much the same as what we did before. You figure out what u should be, and then we change the bounds. So number 1, we have the integral from 0 to 1, 3x minus 1 to the 50 dx. Okay, again, we've got the outside function, something to the power 50. We've got the inside function, 3x minus 1. We let u be the inside function. du will be 3 dx. So we have 1/3 du is dx. Okay, now we need to change the bounds. So the bounds are x equals 0 to x equals 1. So x equals 0. U will then be, well, we've got the expression for u. So 3 times 0 minus 1. So minus 1. X equals 1. So that will be 3 times 1 minus 1. That'll be 2. So these are our new bounds. X, that was the old bounds. U, that's the new bounds. Remember the order. So x equals 0, that was the lower bound. So u equals minus 1, that is the new lower bound. X equals 1, that was the old upper bound. U equals 2, that is the new upper bound. Don't swap them when you're rewriting. So that's the integral from minus 1 to 2. 3x minus 1, that's going to be u. And then the dx, that was the 1/3 du. Okay, so we have 1/3 on the outside. Okay, and now because we have the bounds, we need to find the antiderivative and then evaluate. So this is going to be 1 over 51, u to the 51, from minus 1 to 2. So this will be 1 over 3 times 51, 2 to the 51 for the upper bound, minus, and then minus 1 to the 51 for the lower bound. Okay, you can leave it like that. I'm not interested in the number. I want to see your integration. So this, perfectly fine. Don't waste your time simplifying that. Okay, any questions on this one? All good. Okay, number 2. So we have the integral from 0 to 1, cube root of 1 plus 7x dx. Okay, outside function cube root, inside function 1 plus 7x. We're going to say u is 1 plus 7x. So 1 over 7 du is dx. Okay, again, as we go through, I'm going to start leaving steps out that you should be able to do yourselves. Okay, if you need to fill in the details, go ahead and do that, but I'm not going to spoon feed you with every little step. Okay, now that's done, we need to change the bounds. So x equals 0, u is 1. Yeah, someone said 1. Okay, x equals 1, u is 8. Good. So this will be the integral from 1 to 8. Cube roots of u, that just becomes u to the 3rd. Dx, that will be 1 over 7 du. Okay, 1 over 7, that comes out. U to the 3rd, we're going to add 1, so that's adding 3 over 3. So that will be 4 over 3, divide by that, 3 over 4. From 1 to 8. Okay, so this will be 3 over 7 times 4. Simplify that if you want. 8 to the 4 over 3 minus, if you put in 1, it's just going to be 1. So 1. Again, simplify if you want. I'm not interested in how you use the calculator. I'm interested in this working on the side here and your integration. Okay. The fact that you can use a calculator to simplify, I'm not interested in that. Okay, number 3. We have the integral from 0 to root pi, x cos squared x dx. Okay, we want to do a u substitution. We've got outside function cos squared, so that's a 2. Okay, sorry, cos x squared, sorry, the 2's inside. So the 2's inside there. Outside function cos, inside function x squared, so we let u be x squared. Okay, so we have 1/2 du is equal to x dx. Again, from now on, I'm not going to show every step. Please fill in the details. X dx, that takes care of the x over there and the dx over there. Now we need the bounds. So when x is 0, u will be also 0, because we're just squaring. When x is root pi, u will be pi. We just get rid of the roots. Okay, so this will be 1/2 integral from 0 to pi cos of u du. Okay, 1/2 integral of cos is sine, good. 0 to pi, like that. Okay, sine of 0 is 0, sine of pi. It goes like this in the middle. 0. 0 minus 0, 0. Okay, please remember your special angles there. Sine of 0, sine of pi over 3, pi over 6. Okay, it helps getting the answer quicker instead of going on your calculator. Okay, that was number 3. Number 4. We have the integral 0 to pi over 6 sine x over cos squared. Okay, pretty straightforward. Again, simple rule. If you've got a fraction, if u is the denominator, du will probably be something with the numerator. So if we let u be cos, okay, the derivative of cos, that's minus sine. So we're going to have minus du is sine x dx. Okay, the minus can go out to the front. Okay, and the bounds, 0 and pi over 6. So when x is 0, u will be 1. When x is pi over 6, u will be pi over 6. That's 30, cos of 30, root 3 over 2. Okay, so the minus from the du, that comes out. So 1 to root 3 over 2. Sine x dx, that takes care of the, that will be taken care of by the du. And then we have cos squared, that will be u squared. So u to the minus 2 du. Okay, add 1 to the exponent to make it minus 1. That gets rid of the minus in the front there. So we're going to have 1 over u from 1 to root 3 over 2. So that will be 2 over root 3 minus 1. Okay. Should be pretty easy at this stage. So the only thing new that we're doing is that bit on the right, changing the bounds. Everything else, same as always. Okay, number 5. So we have the integral 0 to pi over 4 tan x dx. Okay, either you know the answer right away, then you just put the answer down. If you don't, we can write tan as sine over cos. So this is going to be the integral 0 to pi over 4 sine x over cos x dx. Again, you got a fraction, let u be the bottom. Okay, so minus du is sine x dx. Okay, when x is 0, that means u is 1. When x is pi over 4, u is 1 over root 2. Yeah. Okay, so this will be minus the integral from 1 to 1 over root 2. Sine x dx, that's du. And then we have 1 over u for the 1 over cos. So that will be minus natural log of u from 1 to 1 over root 2. That will be minus the natural log 1 over root 2. Natural log of 1, that's 0. We can leave it out. You can simplify further. That's not really needed. But we end up with 1/2 natural log of 2. Okay, not needed, but if you want to simplify, you can do that. I think the aircon's broken. It's feeling very warm. Okay, number 6. Little star. So we have the integral from minus pi over 3 to pi over 3. X to the 4 sine of x dx. Okay. At this point, I'm going to remind you that whatever integration problem I give you, it's up to you to figure out what to do with it. You can use whatever technique you want, okay, to answer the question. So here, we're doing u substitution, but all of these problems you need to start treating as just integral problems. So not everything will be u substitution just because we're covering u substitution. Okay, just think of it as integral problems. In this case, we can see that we've got some definite integral. You can try a u substitution, it's not going to do anything. But notice that the function is odd. X to the 4 is even, sine of x is odd, the product of even and odd is odd. If you forgot that, go back to our stuff on that. Okay, and we're going from minus pi over 3 to pi over 3, like minus a to a, something like that. So we've got an odd function over symmetric bounds. It's just 0. Okay, who sounded shocked? Okay, please go back to last semester's work on even and odd functions. Okay, under the section on definite integrals, we covered the 2 cases of an even function and an odd function. Okay, please have a look at that bit. Okay. So all the stuff we covered on definite integrals, that still applies. Okay, just because we're doing u substitution doesn't mean you forget all the stuff we did before. Okay, in this case, it applies. Okay. Last few I'll leave for homework. Same sort of thing. Okay, so we have the integral from 1 to 2, x root x minus 1. Okay, we've seen this type of problem twice now, but now with bounds. Also, when I start showing problems more than once, you should get the idea that it's coming up in a quiz. Maybe, I don't know. Okay, 0 to 4, x over root 1 plus 2x dx. That also looks familiar. Okay. Integral 0 to 2. 3x x squared plus 4 squared dx. Okay, pretty straightforward. Outside function, inside function. You should be able to do that quite easily. And then the last one, integral 0 to 2, 1 over 5x plus 4. We've also seen something like that. Okay, so these last few, please, for homework. Okay, any questions on this for definite integrals? Yeah. Number 4. Yep. You could, but then that's just more work for you to do. Okay, remember, again, from now on, there's always more than one way to do these. You could do it like that. You might get the same answer, but your working might be a bit more complicated. Yeah, there's no fixed rules on that. It just comes with practice. Okay, so try it out the other way. Say u equals cos squared, see what you get. And then when you do it both ways, you'll learn, don't do it this way, do it this way. Then when you see something like this later on, you know immediately what to do. Okay, Again, that's just practice. We'll see with the other integration techniques, a lot of them don't have like set rules like if you see this, do this. It's more like you can do this. Okay. Yeah, so it's like a toolbox kind of thing. You got your tools, it's up to you what to use. Okay, any other questions? Okay, just a quick note on the module rules and procedures form. Please make sure you fill that out and hand it to me by Friday. Okay, if you do not hand it in by Friday, you will not be receiving your marks. Okay, so until you hand in the form, everyone looks lost. I guess you weren't paying attention yesterday. I'll show you here. Okay. Yeah, so on the Learn 2025 page, there's a form called Module Rules. The first page is just some rules from the university on module stuff, tests, cheating, assessments, lectures, whatever. You've seen it before. The second page is just where you fill in your details and sign that you've seen it. Okay. Yeah. Yeah, as long as I get it. Okay, Wi-Fi not working. Anyway, look on the Learn page. You'll see it there, module rules. Okay, email it, hand it in to me as long as I get it before the first assessment. Otherwise, you're going to be seeing a lot of zeros on your Student Central. Okay, very, very important that the department gets those forms. Okay, tomorrow we'll be going through some more definite integral stuff, but not the calculations, more of the proof type problems or show that this is true type things. Okay, so that will be for tomorrow. Then next week, if you want to get ahead in the work, we're going to be starting integration by parts. Okay, so that is in the textbook. Just have a look there, integration by parts. That will be next week. Okay, but the quiz for next week, Monday, the first bit of the quiz on the MCQ stuff will be U substitution. So you're going to have 10 integrals, 15 possible U substitutions. You need to match them up. Okay, so like if I give you, let's just go through an example here. Like number 3. So that will be in the left-hand column, and then on the right will be U equals X plus 2. You need to match them up. Okay, so it's like MCQ. Then the second part will be written. Part 1 will be a U substitution indefinite integral. You've already seen it. Okay. Then the second part, U substitution definite integral. You've already seen it. So the two parts. Okay. Also, there's been a cut in the budget. You need to now provide your own paper for tutorial quizzes. So please make sure you bring an exam pad or something to work on. You will only need like 1 page per quiz. Okay, test you will get paper. The quizzes, I'm sorry, no more paper. Yes. You'll have 30 minutes. I think we had that last semester. Yeah, 30 minutes. So 10 matching problems. It's very obvious. You'll see. It's like this. So you have x plus 2. You just match it up to the x plus 2. It'll be very quick to do. The second part, 2 questions, indefinites, definites, about the same speed I did to finish this. So nothing complicated. Yeah, but 30 minutes. I can give you more time, but then you have less time for the tutorial. We can vote if you want. If you want more time for the quiz, fine with me. I don't mind. Okay. Yeah, but for now, 30 minutes. If you need more, I can give you more. Anything else? All good. Okay, so I'll see you tomorrow.